so we are in 13.5. This is going to solve quadratics by square roots. So there are three ways we're going to be able to solve. The first way we're going to be able to solve is by factoring. The second way we're going to be able to solve is by square roots. And then the next way is going to be the quadratic formula. Okay, with that being said, we've already done a few things by visual. We can do some graphing. We can graph from standard form and vertex form, so two forms. And we'll find more about that later on. That'll actually be more next unit. Now, to start out with square roots pieces, we're going to have to know what a radical is. And a radical is actually the inverse of an exponent. For instance, if I have 81 to the 1/2 power, that's the same as the square root of, whoops, let me do that. So if I had 81 to the 1/2 power, that's the same as the square root of 81. So a square root, basically we're asking ourselves what number times itself gives me that. So the square root of 81 is in fact 9. But when we solve, we have to show all possible. So when I solve and I show all possible, it's going to be like an x squared equaled 81. And we're going to square root both sides to get rid of that square. And then we're going to get x is equal to plus or minus 9. So how do we simplify a radical? First of all, simplifying radicals means leave in a radical form if it isn't a perfect square. So we're going to break down the number by perfect squares. So first of all, here's a list of all of our perfect squares, not all of them, but up through 15. So the square root of 1 is 1, square root of 4 is 2, square root of 9 is 3, square root of 16 is 4. I think you guys get the picture. Square root of 25 is 5, 36 is 6, because 6 times 6 is 36. 49 is 7, 64 is 8, 9, 10, and 13, 14, 15. Now, the square root of x squared is actually x, because it takes x times x gives me x squared. So we're looking for the number times itself to give you the number inside. So x to the 4th power, the square root of that is actually x to the 4 divided by 2, which is going to be x to the 2nd power. Because remember, I told you it's to the 1/2 power. So this would be x squared, and if I were to divide it by 2, it'll give me just x. Here it's going to be x to the 6th divided by 2 there. It gives me x to the 3rd power. So exponents we divide in half, or divide by 2. That gave us, like, 5 times 5 is 25. Okay, so now if we're going to break these down, we're looking for the largest perfect square and then non-perfect. So 8. Okay, I like to use half the number and then start working with my perfect squares from the top down rather than from the bottom up. So 8, half of 8 would be 4. Is 4 a perfect square? Yes. So it's going to be 4 times 2. The square root of 4 is 2, so it's 2 radical 2. 12, half of it is 6. 6 is not a perfect square. Keep in mind, we're looking at these guys up here. So 6 is not, but underneath 6 is a 4. Does 4 go into 12 evenly? Yes. So it would be 4 times 3. The square root of 4 is 2, so I get 2 radical 3. 18, half of 18 is 9. Is 9 a perfect square? Yes. So 9 times 2, and the square root of 9 is 3, so 3 radical 2. Notice I do a cross off, like a diagonal, when I perfect square it, so I know, or square root it, so I know that it's on the outside. 20. I would say 2 and 10, but that's not a perfect square. So half of 20 is 10. 9 does not go into 20 evenly, but 4 does. So we're going to do 4 times 5. And you can write it like this, all underneath one radical, or you can write them as separate radicals. It means the same thing. The square root of 4 is 2, so we're going to bring that outside. So it's going to be 2 radical 5. 24, half of it is 12. Again, I'm like right in through here. 9 does not, but 4 does. So I'm going to say 4 times 6. The square root of 4 is 2, so 2 radical 6. 27. Well, half of that would be about, what, 14-ish, somewhere in there. So if I do 14, 15-ish, I'm going to go nothing, nothing, nothing. 9, though, does go into 27. Also, if you add those digits, it comes up to 9, so you know it's a multiple of 9. 9 times 3. The square root of 9 is 3, so it's 3 radical 3. Okay, the next set, 28. Half of it would be 14. Oh, 7 does go in there evenly, though. 7 and 4. 4 times 7. And the square root of 4 is 2, so it's 2 radical 7. 32. Half of 32 is 16. And 16 is one of my perfect squares, so 16 times 2. The square root of 16 is 4, so 4 radical 2. 40. Half of it is 20. 20 is up here. And it was 4 and 5. So this is going to be 4 and 8. Let's go bigger than that. 10. 10 times 4 is, oh, there we go. 4 times 10. The square root of 4 is 2, so it's 2 radical 10. 44. Half of it is 22, but there's nothing more, so we're going to say 4 again. Times, 11. The square root of 4 is 2, so 2 radical 11. Now notice 11 is prime, so you can't do anything more with that. 10 over here only breaks down to 5 and a 2, so there's nothing perfect in those two numbers. 45, they do add up to 9. So I'm going to say 9 times 5. 5 is prime, so we're low as we can go, so it's going to be 3 radical 5. 48. Half of 48 is 24. So things that are under 24. So I'm going to go back up here and I'm going to say under 24 be like right through here. So 16, does 16 go into 48 evenly? Yes, 16 times 3. Beautiful. Square root of 16 is 4, so 4 radical 3. Okay, the next page. You're going to do this on your own. Now, this first row right here, I know and you know, it's the same as the one on the other side. However, I'd like you to try them without looking back. See if you can do them on your own. But my work is there for you to do a little sneak a peek if you need to. But the goal is that you understand what you're doing. And then 50 through the rest. You should be able to do those on your own, please. And then show them to me. Or eventually here, I'll show you my answers and then you'll be able to get them. I will come back to them. So pause me, do these, and then let's move on. Okay, going back over here, now we are actually going to start solving using square roots. To solve using square roots, first thing we have to do is get the x squared, or x plus something or minus something squared part alone. Once we have that, so look at my example up here. I already have that x squared alone. Now we're going to square root both sides. because the square root and the square cancel each other out. So here I would be left with x is equal to plus or minus 7, because negative 7 times negative 7 is 49, and 7 times 7 is 49. So number 3, we're going to have to make sure that you show all possibilities, all possible answers. That's what that plus minus symbol means. And then, of course, we always have to check for reasonable. So if it's a rectangle, for instance, and you're looking for a length or a width, you can't have a negative value as your x value. All right, so let's start solving this first one. We're going to get the x squared part alone. So it's a one-step equation. We're going to go plus 16 plus 16. So x squared is equal to 16. But I have to get x, not x squared. So we're going to square root both sides. So x is equal to positive or negative 4. Same thing on b. We're going to go minus 25 minus 25. Now I get x squared is equal to negative 25. When we take the square root of both sides, square and the square root cancel, x is equal to. When you put this in your calculator, you're going to get an error because you can't take the square root of a negative number. There's no two numbers that you multiply by them, like by itself, that you're going to get a negative, because a negative and negative is a positive, and a positive and a positive is a positive. So there are no real solutions. Okay. The imaginary solution would be x is equal to, the square root of 25 is 5, but I have a negative here, so that would be negative 5i, plus or minus. All right, then we scooch down, and we're going to divide by 6, and we get x squared is equal to 9. Square root both sides, x is equal to plus or minus 3, because the square and the square root cancel. Okay, the next one, we're going to divide by negative 2, divide by negative 2. So now we get x squared is equal to positive 49. Square root both sides. So x, because square and square root cancel, equals plus or minus 7. On D, you can do it 3 different ways, depending on what you think. Now, if you were to, it's a 2-step equation, however, it could be made into a 3-step equation. First thing we always do is undo order of operations. So please excuse my dear Aunt Sally. So when we're solving, we're going to go from this and up. So get rid of any adding or subtracting on the side with a variable. So we're going to go plus 12 plus 12. 3/4 x squared is equal to now 12. Now that can be a couple different things. I could write that as 3x squared over 4 equals 12 over 1. Undo cross products are equivalent. And so basically 1 times 3x squared is 3x squared. And then we can say 4 times 12, right, because 4 times 12 gave me 48. And then divide by 3, divide by 3. And we get x squared is equal to 16. So x is equal to plus or minus 4. That's one option. Another option would be to get it to this point and multiply by the reciprocal. Cancel, cancel, cancel. Over here, 3 goes into 12 4 times. 4 times 4 is 16. And then square root both sides and get that x is equal to plus or minus 4. And an alternate other way of doing that would be saying that this is 3x squared over 4 equals 12. Multiply by 4 to begin with, make it into a multi-step equation here. So then these would cancel and I'm left with 3x squared equals 48 and divide by 3. Again, x is equal to plus or minus, excuse me, x squared is equal to 16, and then x is equal to plus or minus 4. Any way you slice it, they're all going to be plus or minus 4. On E, I'm going to add 48 to both sides. Now this is going to give me x squared is equal to 48. Now we have to do a little bit of work because we have to break that down. The largest perfect square that goes into 48, because we're square rooting, is going to be 16 times 3. The square root of 16 is 4, so it's 4 radical 3. Plus or minus, because we're solving. On F, similar idea, we still want to get that x squared alone, so we're going to go plus 10, plus 10, 5x squared is equal to 75. Divide by 5 on both sides. X squared is equal to, 5 goes in there once, 15 times. And then we're going to take the square root of that. So x is equal to the plus or minus. Now 15 does not break down. That has 0 perfect squares in it. Because you have a 5 and a 3, they're both prime. That would be all you could break that down into. So it's going to be plus or minus the square root of 15. The last one, we're going to add 11 to both sides. We're going to get 2x squared equals 40. Divide both sides by 2. X is equal to 20. Oops, x squared. Square root both sides. Now we're going to have to break down 20. So x is equal to plus or minus. Now this will be 4 times 5. So 2 radical 5. Now we're going to like bump it up a notch. So now over here, and you're going to see it a couple different ways, even on the delta, but on here, we're going to get the x squared part alone. So for instance, this first one, this whole part right here is underneath the radical. So we're going to square root both sides. So now I've got x minus 7, because the square and the square root cancel, equals plus or minus radical 6. I still need to get x by itself, so we're going to add 7 to both sides. So now I get x is equal to, you can either do 7 plus or minus radical 6, or you could say it's equal to plus or minus radical 6 plus 7. Either way, it's the same thing. I'll take it either way. B. Now this one, if I had 5x squared equals 80, we would divide by 5 first, right? So this portion right here, we need alone. So we're going to divide by 5 and divide by 5. So now we have x plus 1 quantity squared is equal to 80 divided by 5, which is 16. And now we're going to square root both sides. So now the square and the square root cancel. X plus 1 equals plus or minus 4. And now we need to minus 1 from both sides. So now I'm going to have two problems right here. We're going to have x equals 4 minus 1, which is 3. And we're going to have x equals negative 4 minus 1, which is negative 5. C. On C, we want this portion alone first, right, because it has x squared on it. So we're going to say take away 7. So we have 2x minus 3 quantity squared is now equal to, oops, not 3. 23 minus 7, and 23 minus 7 is 16. Then we're going to divide both sides by 2 because we're not finished yet. So now I have x minus 3 quantity squared is equal to 8. Now we need to square root both sides. So x minus 3, square and square root cancel, is equal to plus or minus. Now 8 is 4 times 2, so it's going to be 2 radical 2. And last but not least, we're going to bring over plus 3, plus 3. So now we have x is equal to either plus or minus 2 radical 2 plus 3, or you can have x equals 3 plus or minus 2 radical 2. Either way works just fine. All right, this next one, same kind of idea. We need to get that by itself, so we're going to go minus 1, minus 1. 1/2 x minus 2 quantity squared equals 6. To get rid of the half, we can either divide by a half or multiply by the reciprocal, so multiply by 2. So now I have x minus 2 quantity squared equals 12. Go ahead and square root both sides. So x minus 2 is equal to plus or minus the square root of 12, which would be 4 times 3. So it's going to be plus or minus 2 radical 3. And then our last step here, we have to go ahead and add 2. Add 2. So now x is equal to either 2 plus or minus radical 2 radical 3. Or you could have x equals plus or minus 2 radical 3 plus 2. And we have one more before we let you guys loose on the worksheet, which is, I believe, page 29 and 30. All right, so this last one like this, I'm going to go minus 11. So I get 2x plus 5 quantity squared equals negative 6. Divide by 2, divide by 2. X plus 5 quantity squared equals negative 3. This one, nice work here. When I take a square root of both sides, I'm going to get x plus 5 equals, well, I can't do this, so actually this would be I radical 3 plus or minus, which basically right when you do this, you get an error. So no real solutions. All right, let's go back to this page. All right, down here at the bottom, let's see what we ended up with. If you need to see the practice on those, I will write out how I got them. 50, half of 50 is 25, and that is a perfect square. So I'm going to say 25 times 2. So it's 5 radical 2. Since I'm simplifying, I do not need to show the plus and minus. If I were not just simplifying, if I had an equal sign, I would show all possible solutions. 52. Well, the number 52, we're going to go with halves again, and we're going to say, oh, well, 4 times 13. The square root of 4 is 2. 54, they add up to 9, so 9 times 6. Square root of 9 is 3, so 3 radical 6. 56 divides by 4 times 14, I believe. Square root of 4 is 2, so 2 radical 14. 60 is 4 and 15. Square root of 4 is 2, radical 15. 63, 6 and 3 adds up to 9, so I know it's 9 times 7. Square root of 9 is 3. Oops. 3 radical, not 3 radical 3. 3 radical 7. In my last row, 68. It's even, so 2, let's see, half of that would be 34, but not 32, so nope, not 16, not 9, because they don't add up to 9. Let's try 4 times 17, very good. So we're going to get 2 radical 17. 72, ooh, 9 does go in there, but let's see if there's a bigger one. What's half of 72 is 36. Is 36 a perfect? Yes. So it's going to be 6 radical 2. 75, I know I can do it in quarters, so I'm going to say 25 times 3. Square root of 25 is 5. 80, I know 8 does. 8 and 10, 10 would be 8 times 2 is 16, so maybe 16. Half of it would be 40 and 20, yeah, 16 times 5. Square root of 16 is 8. 8 radical 5. 90. Is 9 times 10, and square root of 9 is 3, so 3 radical 10. And the last one is going to be 16 times 6, and the square root of 16 is 4, so 4 radical 6. If you need more, more problem solving on this part to figure out the process, please come see me.